you guys have seen me, hopefully, up there if you were here at 9:30. Mike Bachner, Director of the Composites Virtual Factory here. Joanne Bader, coming from AES, Additive Engineering Solutions. And so our conversation right now is around printed parts. And what are the pieces of the design, what are the critical quality metrics which are going to drive our printed part design moving forward? So, I'm not going to read off everything. You can look at it at your leisure. But basically, a CTQ is what is somebody going to pay for to get out of a part. So we want to kind of talk about those things, what your experience has been in part design, maybe some of the end uses that you have experienced. I think we have a range of people from material suppliers, machine manufacturers, software providers, hopefully some end users as well. So just wanted to talk about some of the end uses. So in the last session, we talked a lot about there's some people that were using printed parts for on aircraft structures. A lot of talk about autoclave tooling. So what other type of end uses do you all in the room have experience with, or have you seen from the extrusion deposition parts? Where's that? Is that the extent of it?
Construction industry.
Okay. Construction?
Like concrete forms.
Okay. Yep.
All types of tooling, aerospace,
Okay. So I don't think we really touched too much on the construction industry. I know you talked a little bit about some of the projects you were working on, but
Yeah.
so what is it that makes an additive manufacturing tool attractive for the construction industry?
Okay, so that angle will have its own perception on this, but I'd say it's the flexibility. You can make any shape design. You can do it rather quickly.
Okay.
And versus traditional, let's say, wooden forms, what they're discovering is that the number of cycles are much higher than you would get out of the traditional wooden form.
Okay.
Plastic, not metal.
Yeah, I think that goes back to in the last session we talked about 3D printing not only introduces a new way of doing something, but it's for the first time introducing a new material to a lot of these industries. So the construction industry with precast concrete, they'll use urethane forms, they'll use wood and fiberglass forms, but they've never used an ABS carbon fiber form before. The same with the aerospace folks. We talk about high temperature tooling and PPS, carbon fiber, or an Alten or something like that. It's all new territory for them. So with the concrete, it worked out really well. It released better off of ABS than it would on a fiberglass tool. Again, so there's kind of the way I look at it is there's always material performance, and then there's performance benefits of 3D printing in general. So the design shapes, we're doing some molds right now where they're pretty long and they have some gentle swoops to them. That's really hard to do with plywood. Is bend plywood and have to do all that. So for that applications, it's been really good. But getting back to some of these CTQs, so we'll get questions that people would probably ask no matter what kind of material you're using. But they'll ask things like, what's the performance in relation to temperature, pressure? If it's in an autoclave, will the part deform? And, some people out there will think, if I put this, first they think that it's plastic in their mind, right? And if I put this in an autoclave, I'm not going to open the door, it's going to be just goop. And people will ask that question. Or, how stable is this going to be? How strong is it going to be? And, I don't think people notice when you have a PPS that's 1.5 inches thick, it's pretty durable. But it's getting these people introduced to new materials, which I think is just as big as the fact of trying to use them to what additive can do physically when you're making a part.
I think, if I may add, with respect to tooling, what we were most often asked when we had lab tours and we were showing were showing these printed tools, the question that would pop up like from the start was, okay, fine, looks interesting, so we can use this as a tool, but how often, how many times can we use it? So I think this long-term durability point is a very, very important point, especially for the printed tools, because they do creep, especially compression molding when the pressures go higher. We've seen some of the initial tools fail after 15 or 20 runs, so okay, just really prototyping or really, really small series. But what about autoclave? Do we see something? So far, I think, at least that was my that last status, we think that if the pressures are low enough for them to work, let's say for 100 or for maybe 200 parts, I don't know. But these are the questions I think that need to be answered. But naturally, this takes some time.
So I guess, is processing at a high temperature, is that something that makes a lot of sense for us to do with it, or is it something that's more of a room temperature for the construction, precast concrete, where maybe you do have some isotherm, but you're not getting to those temperatures where you're going to have a lot of creep? Is that?
This was not necessarily related to construction, but
Right. But I'm saying that you have molds, but you have much different, processing that's happening on the molds. You probably have a lot more weight that's going to be, acting on the carbon, concrete in it, but then you have different, so there's balance between what's going to define success for different types of tools.
So I might say again, I'm speaking from the thermoplastic side, is we design materials depends on what the use is going to be. So if the room temperature up to as high as 350 F autoclave, sorry about F, but 350 F autoclave environments, and for some pretty demanding applications, aerospace, where we're going to vacuum bag this 100 psi, whatever, and again 350 F. And the concern there is, parts moving because it is thermoplastic, so there will be some thermal expansion going on. But to compare that to traditional in-bar tooling, which has extremely low CPEs, but the cost differential and the timing of in-bar versus a 3D print tooling is a huge incentive for these areas. So,
for that kind of temperature, related expansion, how open do you find people are to being able to predict that? So if we say, well, at room temperature, you're not going to be at your geometry, but when we heat it up, you're going to be at the geometry. We can predict it, we can be there. Are people open to that type of, design for a tool?
yeah, so we've done some work with these guys, and again, to the point where certain materials are meeting those criteria within what they consider acceptable. It's not as maybe zero, dead center what in-bar might have been, but it is acceptable in our opinion. And the confidence factors are growing. It's not fully there yet, and there's some advances that will make materials, some advances will make it in design. That's, I think, the whole simulation approach is going to be very helpful to help these people who traditionally, quite frankly, I said in the last session, I was talking with my DSM buddy over here too, the same thing is, they don't understand plastics. These are new users coming on board to the 3D environment, and you're seeing this. These are people who don't understand plastics, but now they're getting into it, which is good. And this is the kind of thing where we are taking the plastics world is this big, now we're making the plastics world bigger, which is great. So we're bringing more people in, more opportunities. There's a lot of growing, a lot of learning has to happen. I think the simulation is going to help these early adopters to come on board and accept this technology.
I think people still want to see real data though.
Yeah.
I think the simulation is great, but they want you to show them. They want
Right.
to see measurements off the parts, right? They want to see measurements off the parts coming off the tools, or they want to see measurements on the tools. And then I think once they see the actual data, then maybe the simulation will be acceptable, more acceptable. Sure. Assuming it agrees, which I'm sure will.
Right.
So misconception that I come across quite often from people that mostly know the idea of additive but haven't worked with it, that everybody actually thinks it's net shape, where that's almost all the time near net shape.
Yeah.
Right.
So the post-processing is completely underestimated, and then people say, oh, it's actually more expensive, and it's more time involved, right? In a lot of cases, post-processing takes as long as print.
Right.
sometimes even.
What we find, so at AES, we make tools for a variety of industries, so construction, a lot of aerospace. And what we see with the benefit is because it's near net, it's a lot less machine than a traditional, a block or a billet of aluminum or gluing up foam and having to machine it. I'll see parts where it's like 100 hours of machining. And since when we near net our prints, they're within a 1/4 inch, 3/8 inch of its final dimension. So we spend a lot less time machining. So sometimes the near net print might be more expensive than that block of aluminum or the stacked up foam, but the machining time's a lot less, and that's where the economics really helps for additive that we see.
For some parts.
Yeah.
It seems like a, kind of a common thing we've talked about this group and then also the group before is education. And, you talk about introducing people to plastics, but then also composites in general and what is anisotropy? What does that mean? What is, how can we deliver that education to people? Is it just, every time we have a meeting with a customer, we just one-on-one teach them? Are there ways that we can have better, broader, industry-focused education activities? I know that through IAPI, we've had a few different events with different companies that, Composites One that does some, kind of training sessions on different composites and materials. How can we bring that to extrusion deposition and additive manufacturing?
Along the line, there's a skill set that we're gonna have a shortage of are people who can understand this kind of software, slicing software, people who are running machines, are really adept at, that skill set, which I think, I don't know, and you might see out there that you're actually, run a band type machine, you have trouble getting people with those kind of skills.
Definitely. I can't go find someone who's run a large scale machine. There's probably only a handful probably in the world. It's, there's translatable skills even from the smaller machines for sure. Usually what we're doing, we like to tell customers who are used to the smaller type machines that stick one of those parts under a magnifying glass and you've got a bam thin part, right? Everything's magnified and you can see the ridges, you can feel them. That's definitely going to be a big one. But yeah, educating the customers. Luckily, there's some more transferable skills from, when we talk to composites folks who've been in composites for a long time. They understand when we start talking about extrusion and the fibers aligning in that path. Then the light clicks for them and they go, oh, so the CT is really good in this direction, but it's really bad in this direction. Yeah. So the composites industry, we feel have been they get it pretty fast. But yeah, the other industries, it takes them definitely a little bit longer.
I think a lot of it started with some of the professional societies, SBE, academia, maybe start having some things, general education on additive, as a reference that people can go to. You don't see a lot of that right now. So a lot of times it is, you go and someone start talking and you're kind of educating on the fly, right? Because a lot of people just don't know. But I think that helps, because I think that could be done in some of the professional societies.
I think getting, Greg, back to what you were saying, you need real numbers, right? And that's definitely pretty hard. When you're talking, high temperature tools, and it's like, hey, well, this tool to produce it is going to cost us $25,000, and then you need someone to test it X many times, and they're not, cheap, easy ways to do all that. So honestly, that's probably one of the biggest roadblocks. Is, hey, yeah, we could probably figure out a lot of these things on my list that customers always ask, hey, the durability on it. Well, no one's taken a 3D printed tool and laid up on it 500 times. At least I have. In the large scale side. So, do you find a couple people who are willing to do that and it's going to take a few years until they reach number 200 or 300? Or, do you get the money up front to just put it through the ringer and go at it.
Yeah.
Luckily, the concrete guys are really easy to work with, and they, you know, I think it started off at Oak Ridge, and then we took over some of that work, and within a year period from like the idea of it to them casting 200 concrete parts off of one mold, that all happened within about a year. So that doesn't happen that fast in most industries.
Concrete's one of the original composites, so.
Right, yeah. So some of the, I kind of have like a list here, and I went over some of it, but I'm sure you've seen it as people come by and ask questions. You know, we get things like vacuum integrity a lot. You know, surface finish. Do you need a coating, or can you just smooth out the printed part itself? You know, then there's some things that we might not think of right off the bat is, repair and maintenance. What happens if the guy, you know, runs a forklift into it and makes a big, chip out of it? How do you repair that? So, you know, those are just more things that we have to deal with and try to figure out. A couple of the guys in the last session we're actually doing some projects with to try different gap fillers and adhesives on these things. And then you've got different properties, and you try to get a gap filler or an adhesive that's as close as property to your base material that you're printing with, but you can't always do that. So thermal conductivity is a big one as well. If you put it in an autoclave or an oven, it's plastic, it's not going to heat up as quickly as a steel mold, but maybe this printed part is hollow, or it's sparse infill, so heat's able to go from underneath the face sheet of the tool as well and heat up. I mean, there's just a million different things that on our side that we see from customers that we could test out. And we talked about in the last session was how do we get everyone to come together to test it out, because I've got a project with this customer, and I've got a project with this customer, and I can't really share that data with this customer, and our customer's not sharing all the data back to us either. So it's, how do we get everyone to agree to say, here's the top 3 things we need to figure out to push this forward, and how do we get together and do that?
Yeah, I think repairability is a big thing. That's a good point. Some of these tools are quite large, you can 1,000-pound part easily, and if you get 3/4 of the way through it and have a hiccup in the extruder, or nick happens or get a stress crack somewhere, just throw 1,000 pounds of material away and how many in 10 hours of print time.
Yeah.
So repairability, I think, is
How about recyclability? Have you actually, that's maybe a question, have you had the case that the customer comes back, right? That you had this situation where print fails 3/4 through the job?
Yeah.
And have you tried to just put it in a big grinder and get the material back and use it again?
Yeah, so we've looked down that route a couple times. It's difficult, number one, when you have, people that normally do that for injection molding, they're dealing with, a few millimeters or, less than that thickness, and we're dealing with, maybe an inch thick or 2.5 inches thick of just pure plastic. Number one, so finding a grinder that powerful to do that. And then 2, a lot of these people don't, from what we've seen, don't want to regrind when there's carbon fiber in it or a glass fiber. That's an issue. Number 3, they don't want to take it unless they've got like 2 truckloads worth of it. So I feel like everyone that's coming to our facility has asked us, how do you redo this? Because the concrete guys, when they're done, with that building, now they've got 20 forms and it's 20,000 pounds of thermoplastic that they don't need anymore at all.
But it's been contaminated with different things, and so how do you?
Yeah, right.
Yeah, I think that's something that I was really thinking about. But it's a great point. End of life for a part that's definitely critical for especially in our current do we deal with all these things that we have 20,000 pounds of material that's just sitting there?
Yeah, we're actively looking into that right now, closed loop type of arrangements.
We've used recycled material, not recycled from our process, specifically. And, typically what we'll do is we'll use them that'll be what we use for prototypes or mock-ups. If we don't know the performance metrics of that recycled material, right, then we use it for the non-critical things. But there's plenty of those to go around to use.
Yeah, finding other uses for the material, not necessarily it has to come back directly into the printing process
As a tool or
as a
something.
tool, but maybe for the hybrid injection molding, maybe for some other area where, having fibers in the material is critical for maybe thermal expansion or something like that, but not necessarily for the strength, because I know that we see once you grind the fiber up, at all, you lose all your strength, and now all of a sudden your performance is going to take a huge hit on you.
And the other thing too, they put like a post-treatment on a surface treatment of some sort. Now you got no contamination.
Right. Yeah, and I think that's a big question about the recyclability is the pedigree of the material that's coming into you. What's happened to it? Even what's happened to it in its thermal history? Have you degraded any polymer, in any of that process?
I think another big one is when we get on, ask all these questions on the performance, of the material. The big thing is most all of the data is injection data. People are working on getting more data on the specific additive process. But we talked last meeting about, us as a company, we're trying to consistently and constantly improve our printing process. So whether we're using a new style of tamper or we're going from, a bead that's a 1/4 inch wide to a 1 inch wide bead, how does that change? If Tom spends all this time and Andrew, I give you all this great, additive data now. It's like, well, that's great, Tom, but we're using a roller now instead of a, compacting tamper, and we're using a bead that's 3 times as wide. Does that affect all those properties that you tested for? So if we as an industry are constantly upgrading machines and different ways of processing, are we having to recharacterize and evaluate those metrics every 6 months, right?
Yeah.
And that's where the simulation, could hopefully come in and help with.
And just those kind of changes that you mentioned, Andrew, going from a tamper to a roller, change the bead from this to that. We talked about in the last session is if this particular application has a flammability requirement, a well rating type thing, now you're just throwing out the blue card. You need a whole new blue card.
Yeah.
Changed one little parameter in the process.
Yeah. We talked about flight certification last time. It's kind of the same thing is if you want to get a part on an aircraft, then you change one part of the process. Change one part of the design, you're kind of back to square one. So
No matter how minor it is, call it out.
I think we have about a minute left before the session will rotate. So anybody have 2 minutes left, I guess. So anybody have any kind of closing thoughts? Maybe something that's been on your mind that you haven't been able to fit in? I think one of the things that has come up is standardization. How do we create standards for this? Is it that we rely on the professional organizations, to kind of drive that standard making process? What are your thoughts on part design standards?
Other than we need them.
Yeah, I think we need and preferably one.
Right. And I've been in some calls with some OEMs, and it's really difficult for them to figure out should they standardize for polymers and metals in one standard or not, and it seems to be an ongoing, many month-long debate. So I don't think they're sure what they want to do yet.
Yeah, that seems like a pretty common thing, is that people don't know what they want to do. So kind of holds it up. So I think that will probably close this session.